Boston once decided to do something almost impossible. Instead of tearing down a highway, they chose to hide it right underneath a living, breathing city. What followed became one of the most ambitious engineering projects in American history, and also one of the most expensive. This is the story of the Big Dig. By the middle of the 20th century, Boston had a problem that just kept getting worse. Its main highway, the Central Artery, cut straight through downtown. It was elevated, noisy, constantly congested, and it split neighborhoods apart. Traffic grew far beyond what the road was ever designed for. By the 1980s, gridlock wasn't an exception. It was the daily routine. Boston needed relief. But instead of expanding outward, the city chose the bold option. They would take this highway and bury it underground. On paper, the idea sounded almost elegant. Put the traffic below ground, reconnect the city above, create parks, green spaces, and a better urban core. But doing this meant building massive tunnels directly beneath one of America's oldest cities, and doing it while traffic above kept moving. No pause button, no empty construction site. The city would have to stay alive during the build. From an engineering perspective, this was where things got serious. The Big Dig wasn't just big, it was unprecedented. Engineers had to dig through unpredictable soil, work next to historic buildings, and manage underground water from Boston Harbor. So they invented solutions on a scale rarely seen before. This project used one of the largest slurry wall systems ever built in North America. It relied on extensive ground freezing techniques just to keep soil stable long enough to work. And it included what became the deepest underwater highway tunnel connection in the United States. All of this was tied together by one of the world's widest cable-stayed bridges, the Zakim Bridge, built right above the tunnels. From a purely technical viewpoint, this was engineering at the limit, and for a moment, it looked like it might actually work. When the Big Dig was proposed, it came with a price tag, about $2.56 billion. Expensive, but manageable. Then reality arrived. As construction continued, the estimate climbed. First to around $7.7 billion, then past $10 billion. By the time the final sections opened, the total cost had reached roughly $14.8 billion, more than 5 times the original estimate. This wasn't just inflation. It was a combination of underestimated risks, unexpected ground conditions, environmental mitigation requirements, and constant scope changes as problems appeared underground. Each fix made the project safer, and each fix made it more expensive. Here's the uncomfortable truth. From a technical standpoint, many parts of the Big Dig worked. Some of its solutions are still studied today. But megaprojects don't fail only because of bad engineering. They fail because complexity multiplies risk. Every assumption made early on becomes fragile once reality pushes back. Boston didn't just dig tunnels. It discovered how hard it is to control cost and risk when a project reaches this scale. Even with experienced contractors, advanced planning, and constant oversight, things can still spiral. NASA described the Big Dig as proof that even the best teams can be overwhelmed by megaproject complexity. Was it a total failure? Not exactly. Traffic flow improved. The city above changed dramatically. Neighborhoods were reconnected. But financially, the Big Dig became a warning, a reminder that when we push engineering to its limits, the price isn't always paid in concrete and steel. Sometimes it's paid in billions. The Big Dig showed what modern engineering can achieve and what it can lose. So here's the real question. If you had to decide today, knowing everything Boston learned the hard way, would you build it again? If you want more stories about mega projects that pushed ambition too far, this series is just getting started. This was When Megaprojects Fail.